So we've wired two dissimilar modules, this module here and this smaller module, in series together. So we've wired the negative from this larger module to the positive of the smaller module, and that's our series connection. So now we have two 12-volt modules wired in series together, and these are our home runs, a positive and a negative, that we could run back to our charge controller and charge a battery. And so we'll get, since we have two 12-volt modules that both get 20 volts open circuit individually, when we wire them in series together, we're going to get 40 volts open circuit because voltage is additive when we wire in series. And since they're dissimilar modules, we actually lose current production from this larger module, and it goes down to the smallest common denominator of the smaller module here. So when we have dissimilar modules, we'd rather be wiring them in parallel together, which we'll do here in just a minute. The same two modules that we looked at a second ago, and now we've wired them in parallel. So we've wired the negative from this large module, okay, up to the negative of the small module right here, and we just wired in these little tester leads as well. And then we took the positive from the large module, this red one here, and wired it to the positive of the smaller module. So in parallel we wire positive to positive, negative to negative. Then we just took these little two tester leads that I have in my hand here. We tied a knot in the positive test lead, and then this is our negative test lead. And what we saw was, when we wire these together in parallel, the voltage remained the same. We got 20 volts open circuit, but the amperage added, and we got about 4.6 amps between the two for a total of 92 watts. When we wired these two modules in series together, we were only getting 52 watts. So a good example of dissimilar modules and why we want to wire them in parallel rather than in series.